4.8 talks about the concept of negation. These are some applications, specific really. Applications have to do with gravity, velocity, and initial height. Recall, if s is the position of a particle, velocity is the change of s with respect to time, and acceleration, denoted by a, is the change in velocity with respect to time, which is pretty much the second derivative of s with respect to time. S is the position of an object, v is the velocity, and a is the acceleration. Assumption: the actual value of gravity is 9.8 meters per second squared. This book assumes it's 10, so anytime you're using that other than this class, you would be using 9.8 instead. But to make things simple, this book uses simply 10 meters per second. And an object in free fall can be modeled by pretty much acceleration is due to gravity. And a equals negative g, which is negative 10 pretty much. That's on any problem that deals with height, tossing something up. Of course, on Earth, on different planets, gravity is different, but it's the same procedure. That will change depending on where you are. So first, I need to remind you how this works. If I'm looking for having an equation and I want to solve with an initial value, so this says when x equal 1, y equal 4. So if I want to solve this, I would cross multiply, and I would simply integrate, and I'll get y to equal x to the 6 over 6 minus 3x plus a constant c. So that would be my equation, except in this case they gave me the initial conditions, so I need to solve for c, and that would be where this point is. Y equal 4 when x equal 1. So that would be 24 equal 1 minus 18 plus 6c. 24 equal negative 17 plus 6c. If I add that, what is that? 11, 30, 41. So c happens to be 41 divided by 6. All what you would do, you would take that original equation and say y equal x to the 6 over 6 minus 3x plus 41 over 6. And that's pretty much how we do a problem with an initial condition. Now, every problem in here has initial values. You just have to make those out. So starting with, I'll read them off. An object is tossed up in the air with an initial velocity of 10 meters per second. That's initial velocity, and you could tell that from the units if you're ever confused. So going up is positive, coming down is negative. How long did they stay in the air? Well, think about it. An object is going to be tossed up. It's going to eventually come down. Well, assuming air resistance is negligible, wherever the velocity equals 0, that's when you hit a peak. That's a must. You must understand that idea. And the length of time with compared to the height is twice that peak. This time equal that time. So the idea is to figure out the velocity function. We start with acceleration is negative 10, right? And let me fill in the units, that will be better. dv dt is 10. So if I cross multiply and I integrate, I will get the velocity function. The velocity for this is 10t plus initial velocity. Since they gave me initial velocity, now I'm going to do this only in the first problem. V of 0 is 10 times 0 plus V sub 0, and that should equal 10. So that's going to be 0 because it's always initial. So instead of doing this step, I would start skipping and writing 10t, and every time there's an initial velocity, I would pretty much fill in what I'm given right away. Now, I could solve for s and set s equal to 0. So if I solve for s and set s equal to 0, that will tell me the initial and the terminal. Or I could take the velocity. Oh, that was a negative. I lost track. That was a negative then, right? Otherwise you can have negative time because, and it's due to that you figure things are up or down. And if I set that equal to 0, I'll notice that negative 10t equal negative 10t equal 1. So this is going to take it 1 second to reach the maximum height. When it says how long does it stay in the air, well, it stays in the air for the entire time is 2 times 1, which is 2 seconds in this case. And that's pretty much how you're going to answer these problems. Some of them ask for position, but you need to understand really how this works. So when I look at the second problem, a ball is thrown upwards with a velocity, so v sub 0 is 20 meters per second in this case. How high does it rise? How high does it rise? Well, doesn't it rise this high? So to figure out how high it is, I need s. Here I solve for s. First, let me get the equation, then I'll elaborate. Well, the change of velocity with respect to time, which is acceleration, is negative 10. And if you cross multiply, and if you integrate, you're going to get the velocity function to be negative 10 t plus v sub 0, but v sub 0 is 20, so I could skip that step and figure out the velocity right away. Now I'll come back to this. I need this equation for something else. For now, I'm going to go for s. S is, I should say, the velocity is ds dt, and that's negative 10t plus 20. If you cross multiply, ds is negative 10t plus 20 dt. So now I'm going to start integrating from this stage, knowing that we cross multiplied, and I can get the position of this ball at any given time. It's add 1 to the power, divide by that, plus 20t plus the initial height, but the initial height is 0 because they said you toss it up. They didn't say from a hill or a building, or so we assume that's 0. That is the position of the particle at any given time. This is in meters. To figure out how high it goes, well, again, where the velocity equals 0, so v equals 0, that is when t equal 2 seconds. It's going to take it 2 seconds to reach the maximum height. Well, what's its position in 2 seconds? That's negative 5 times 2 squared, which is 4, plus 20 times 2. That is negative 20 plus 40. So its position, the maximum height it will reach, will be 20 meters. Again, fairly simple if you understand that anything that you toss up will come up and back down. That's these type of problems. Example 4 says, a stone is thrown upwards with an initial velocity of 5 meters per second. Okay, from a building top that is 60 meters high. So here we have the initial height to be 60 meters. It's no longer 0. How long does the stone take to hit the ground, and with what speed does it hit the ground or strike? Well, okay, let's start again. Find the equation first, then we elaborate. Acceleration is dv dt, and that is negative 10. If you integrate, you'll get the velocity to be negative 10t plus initial velocity, instead of putting v sub 0 and solving, well, it's 5 right there. I got the velocity. And I know that the velocity is the change of s with respect to t. The reason I'm solving for that because it's asking how long does it stay in the, how long does the stone take until it hits the ground and with what speed. So speed I need, it's the absolute value of velocity, but I need the time to figure out where it hits the ground. Well, that is negative 10t plus 5, and if I integrate, I'll get the position to be add 1 to the power, divide by that, plus the initial height, but I know the initial height is 60. So that tells me the position at any given time. Now, if I take s and I set it equal to 0, that should tell me how long did it stay up in the air. So in this case, 0 equal negative 5t squared plus 5t plus 60, divide by a negative 5, 5 divided 60 12 times. Yeah. So that would be t would be 4 or negative 3. Well, it's going to take 4 seconds to hit the ground. So now I go to the problem and say, well, let's see. How long does the stone take to hit the ground? It takes 4 seconds. I compressed all of that stuff here. It takes 4 seconds to hit the ground. That's the first answer. And when it says with what speed, the velocity at 4, and that's that equation, is negative 10 times 4 plus 5. The velocity at 4 is negative 40 plus 5, negative 35, and speed is the absolute value of velocity, so that's 35 meters per second. That's how fast it would hit the ground. And here's another problem. A rock is dropped from a height of 30 meters, that's the initial height, into a hole that's 8 meters deep. Okay, I'll get to that in a minute. How long does the rock take to hit the bottom of the hole? Not the ground, of the hole. I'll get to that in a minute. And with what speed? Okay, so a rock is dropped, it wasn't tossed. The initial velocity is 0 because you just dropped it. Acceleration, which is dv dt, that is negative 10. If I integrate, I'll get v to be negative 10t plus 0, right? Which is negative 10t. Pretty much that's a velocity. You don't have to write plus 0. I'm just writing that for your notes. Now, v is ds dt, and that is negative 10t. If I integrate, I'll get the position of this particle, negative 5t squared, plus the initial height, which is 30 meters. That tells me the position at any given time. Now, if I look closely, it says it's going to fall into a hole that is 8 meters deep. It's 8 meters below the actual 0 level, or the ground level. That is negative 5t squared plus 30. Negative 38 equal 5t squared. And here I'm solving for time. So t squared equals negative 38 over negative 5. And that would be, if I get my calculator out, and here it is. If I take, oh my god, it hates the pointer, it wants the actual mouse. If I take 38 divided by 5, so roughly 7.6 seconds, and if I squared with that answer, it'll take about 2.8 seconds, roughly 2.8 seconds. That's what t equals, right? So if I know the time, then I could figure out, well, that's how long it takes. So how long does the rock take to hit the bottom? The rock takes 2.8 seconds, roughly, of course, to hit the ground. With a speed of, and what is the velocity at 2.8 seconds? So if I take the velocity at 2.8 seconds, that would be, well, I don't need a calculator, right? Negative 28, so 10 times, but if the problem was a bit, or the numbers were a bit messier than that, velocity is negative 28, indicating that it's coming down, and of course speed is the absolute value of velocity, which is 28, with a speed of 28 meters per second. And that's pretty much all there is for this section.